Hi there. Today I'm going to be teaching you about electric circuits. And electric circuits is somewhat of a tricky topic, and it has a lot of math involved, but I think it's really easy once you understand the main formula, which I'll discuss later, and like the some of the concepts. So I wrote down a few notes. As you can see, series circuit. So, if you don't know already, there's two types of electrical circuits. Well, three. They could be in complete series, which would mean that there's a battery. This is the symbol for a battery. And there could be something like, let's say, for a resistor, for example. And then just like that. And then we could even have a light bulb, for example. So you see over here, it's in a series. So this comes first, this comes second, this comes third. Like, there's no any branching off. That's how you know that's a series circuit. So when you look over there, REQ, which as I wrote over here, is basically the short form of equivalent resistance or effective resistance. So there's different ways to say, as you might notice or know already, there's different ways to say different symbols. So like that, in a series circuit, it's really easy to find the REQ. The REQ is R1 plus R2. So let's say this is R1 and this is R2. Then we would just do, and let's say if this was 10 ohms and this was 5 ohms, then REQ would be R1, so 10, plus R2, 5, equals 15. And don't forget the symbol, it's still resistance, so it's going to be ohms, like that. And there's a special thing about series circuit, and in that, the special thing is that the current always remains the same. So the current over here is going to be the same, over here it's going to be the same. No matter where you go in the circuit, basically, in short, the current's always going to stay the same. So that's for now, for the topic that I'm going to teach, which is going to be mixed electric circuits. This is basically the foundation which you need, and I feel it's simple enough. Next, you get parallel circuits, and this one's a bit more confusing to some people, but it's really just as easy as series, and you could do the same thing. Over here, if you want to find the REQ, you would use this formula. So basically, the inverse of REQ. And this is the actual formula, so in case the teacher wants you to show your work, this is how you do it. But don't worry, there's a much faster way to solve for REQ. And if you're allowed to use a calculator, that is. But in short, this is the formula. So 1 divided by REQ, which is most likely going to be X because we wouldn't know, equals 1 divided by R1. So if we go back to this example, R1 would be 10. So 1 divided by 10 plus 1 divided by 5, because that's R2. And then if I'm just assuming for this time being that there's going to be 2 resistors, but the dots means that there could be like 50 resistors, and you would just continue. So 1 plus 1 divided by R3, 1 divided by R4, etc. And in series, if you remember, current remains the same. But in parallel circuits, the voltage remains the same, meaning that the number of volts over here are going to equal to number of volts over here. And if you don't know what a parallel circuit looks like, it's basically like this. You see how this is like a complete parallel circuit. So basically you see how this resistor and this resistor are parallel, so like they're never going to touch. The battery is parallel, it's never going to touch. They just keep on going like that. So in this, the voltage remains the same because it's from here to here to here. So that was the foundation of it, and I'm going to now teach question which I feel is pretty complicated. So this is the question. We have a diagram which tells us that the batteries it is equal to 120 volts. Then there's three circuits. Circuit 1 has a resistance of 10 ohms. This horseshoe sign is called an ohm. Resistor 2, which also has a resistance of 10 ohms. And resistor number 3, which has a resistance of 15 ohms. So we're supposed to find the current and voltage across each resistor. So 1, 2, and 3. This seems complicated because it's hard to tell how would you tackle this type of question, because it's not a complete series because there's this parallel, and at the same time it's not complete parallel because there's this one which isn't parallel. So I wrote down a few tips on how you would solve something like this, and really I could go and make longer tips, but there's 2 tips in general which you should do for every question that's like this. You should find the REQ. So like I discussed above, we already know what REQ is, but you should find the REQ of the circuit, because like of the total circuit and of the and of just the parallel ones separately. That's going to be really useful because then using that, and we already have the voltage from the battery, we can find the current on the entire circuit. And I'll show you exactly how I do it, but that's basically what I'm trying to teach. How you would solve this. So like I said, if you don't know already, the formula, which I wrote down over here, we're going to solve for the parallel first. So we're going to find the REQ of the parallel circuit. And if you look over here, 1 over REQ equals 1 over R1 and R2. So it doesn't really matter which one you call R1, but let's just say this one's R1 and this one's R2. Then obviously this would be R3, right? So this is the formula, but like I told you, there's an easier way, a much easier way you can do it, and it saves you a lot of time, so you don't have to waste time on applying this entire formula. You should still know this formula, because if any case the teacher wants to know how you got the answer, you could write it down on a test or on a worksheet, and it would just work out like that. But I'll keep that over here. And so over here, let's just write the formula down again though. 1 divided by REQ equals 1 over R1 plus 1 over R2, right? Because, and you wouldn't put the dots because there's only 2 resistors in the parallel form. So R1 is 10 ohms, right? As you can see here. And R2 is 10 ohms. So instead of doing that, if you don't know what the inverse function is, this button right here, it might be different on different calculators, but for my calculator, it's this button right here, x minus 1. And basically, it basically does this. So for example, 1 over 10, right? Because that would be R1. If you do it without a calculator, you would get 0.1 without the inverse functions. But at the same time, you could have just done 10 inverse and you will get 0.1. Exact same numbers. So we can use that to really help us out. So I'm going to do it on a calculator. Let me clear it out. So R1. Look over here. R1 is 10 ohms. So we would do 10 inverse plus R2, which is also 10 ohms. So we would do 10 inverse. So from that we get 0.2. Now notice, 0.2 only equals to 1 divided by REQ. And so don't stop right there. Instead, what you should do is get 0.2, which was our answer addition of the both, inverse. So you get 5. So REQ of the parallel is 5. And the reason why I did 0.2 inverse is because if you look at the formula, it's not just REQ equals 1 over R1, it's 1 over REQ, which is also the same thing as saying inverse. So that's the symbol for inverse, but we can't write inverse there. But REQ equals 5 ohms. And like I said, so we accomplished the first part of the problem, and now we have to find the current throughout the circuit. So to do that, we have to use the most important formula for this chapter, and that is R resistance equals V voltage or potential difference over I current. In this case, we're going to use, instead of R, we're going to have REQ. But note that this REQ is 5 ohms, but that's only for these two together. If we wanted the complete REQ, then we would make it in the series form. Because see, what happened right here was, just imagine once you find the REQ, just imagine for the time being that this doesn't exist, and this is just one resistor with 5 ohms. And then if you notice that, here, let me cover it. And if instead of the 10, it's at 5, you would see how it would become a series circuit. And over there, to find the REQ, you would just add. So REQ equals 5, which we got as the REQ over here, over plus 15, which is 20 ohms. Alright, so we have to find the current. Current equals V over R, and we know the voltage is 120. REQ, sorry. And 20 is the REQ. And if we solve that using a calculator, you would get 6. And don't forget the units, because that's really important and you could lose marks there. So it would be 6 amps or 6A. Alright, so now we know that this is going to be 6A. And remember from from the tip I said earlier, current remains the same in a series. So obviously this isn't a series circuit, but this would be part of the series. So that means we already found one part of it. Current equals to 6A. Because current's always going to stay the same. It could be here, here, or here. Right? And it's always going to stay the same. So over here now we have, if you look at our formula again, I equals V over R. Or really what it is R equals V over I. Let me move it up a bit. We have I, we have the R, which is the resistance. So all we really need to find is voltage, right? So resistance is 15. V is unknown, and I is 6. So from algebra, we should know that 15 times 6 equals V, and 15 times 6 is, let's use our calculator, 15 times 6 equals 90. So 90 equals volt. And remember, this is going to be in volts. So V equals 90 volts. So the good news is we already finished the first half. Now we just have to tackle this part. So to find this, remember how we found the REQ? And I recommended that you would do it separately and not just a complete REQ total. So we can use it to find the voltage, because remember our second tip, voltage always stays the same in a parallel circuit. So the voltage over here and here is going to be exactly the same. So we would use I equals V over Req. Imagine that this is, again, a series one, so we get a chance to use this Req 5. And if it would be a series one, the current would stay the same, remember? So it would become 6 equals V over 5, or simply 6 times 5 equals V. So 30 volts equals V. So if that's over here, it's going to be here too because they're in parallel connection. 30 volts and 30 volts. So the good news again is we just need to find the current. To find the current, all we would do is I equals V over R, and let's just call this I1. I1, R1. So voltage 30 and resistance 10 equals 3 amps. And I2, okay, let me write that down here, 3 amps. And I2 would be 30 because the voltage always stays the same. And in this case, the resistance is also 10, so 3 amps. Therefore, thus we solved the problem. The current and voltage across the first resistor is 3 amps and 30 volts. The second resistor, 30 volts and 3 amps, the same thing because the resistance were the same. And the third resistor, 6 amps and 90 volts. I really hope I helped you learn how to do mixed circuits, and I'll try and get another video next time. Thank you.